Nice to meet everyone. My name is Kris Elfland. I lead engineering at Deepgram. Today I'm going to talk you through about the shift from basic voice interfaces to real-time production-grade voice agents deployed today by Fortune 100, Fortune 10 companies. At Deepgram, we believe the future of voice AI isn't about just perceiving speech. It's about really acting on it. From phone calls to drive-thrus, voice is rapidly fulfilling our sci-fi dreams of becoming the most natural way we talk with machines. But delivering on that requires a whole new kind of infrastructure. It's real-time, it's streaming first, and it's deeply integrated with native voice foundation models. I'm going to walk you through what it takes to get there, the challenges we see across all the industries we serve, and what breaks when teams try to scale their solutions. So Deepgram, if you're not aware, builds the foundational AI stack that makes voice possible end-to-end. That includes voice deep learning, scalable infrastructure for massive data handling, and the ability to train and host thousands of models. Our goal is to create the foundational AI that can perceive, understand, and interact through speech. So voice is core to our experience as humans. There are over 1 billion voice interactions every single day in the enterprise. This includes call centers, sales meetings, medical appointments, drive-thrus. All of this is happening today at a massive scale. So here are some of the use cases that our customers and partners are transforming today using real-time voice AI. So we power everything from telephony and call center platforms like Twilio and Salesforce, everything from service assistant agents or agent assist, customer co-pilots, including even complex medical transcription and pronunciation, and even drive-through voice agents at Krispy Kreme. But building this tech reliably is very, very difficult, and this is kind of where it gets tricky. So let's go ahead and dig in. So generally when customers come to us and they're building voice agents, they often tell us the same thing, right? Voice is very high volume, it's very error sensitive, and it's time critical, right? Perception, quality, and cost. These are the hardest 3 problems to solve. Just to be super clear, voice is not text with audio. It introduces things like turn taking, emotion, intonation, and actually creates a very much deeper experience and a human interaction. So what I mean by that is we're talking about human behavior now, right? Humans can multitask. They take turns. They apply and synthesize context, right? They express emotion. And we do this all together in real time when we're having a conversation. So if I get on the phone with a voice agent and I start interacting with it, the human mind is already preconditioned, thanks to evolution, to implicitly expect the AI to mimic these dynamics automatically and still be functional and efficient. Anyone who's messed with this stuff knows that's a really tall order. And that's actually the problem, right? Most voice systems today struggle with fluid turn taking or detecting interruptions. They also have a hard time dealing with context and responding with context in a real-time way. And if they can't end up taking any sort of real action, then it just becomes an audio tour guide handing you off to the next department to hopefully get your answer resolved, right? This is what makes voice so uniquely challenging. It's not just about accuracy or enunciation, it's really at the core about human behavior. So let's just kind of talk about the typical journey real quick in terms of what teams typically go through when they're building these voice agents, right? So when you start at the prototype phase, you're really just trying to get something working, right? You're focused on speed. So you'll put up with maybe some higher latency than you should. You might miss a word or two, right? Or you might have some sort of brittle data pipeline that you've kind of thrown together to get it working, right? You're really just focused on getting the concept working. So once you move into production, things start to change, right? You need to figure out how to handle interruptions elegantly, or barge-ins, right? You need to handle end of turn. Make sure you know when someone is done speaking, otherwise your transcripts start to flow together. And then accuracy takes a really front and center position, right? You have to have much tighter feedback loops in terms of your customer feedback and the product you're building. And then at scale, your bar gets even higher, right? You need sub 200, 300 milliseconds in order to actually provide a realistic, fluid experience. You have to worry about compliance. Who here has to worry about compliance issues as part of their products? right? A lot of you. So this includes full observability and orchestration across both your speech and your reasoning layers, right? And so voice is not like other interfaces. It requires a purpose-built stack that solves the unique challenges of voice. So to solve this, you need more than just accurate voice and text models. You need runtime orchestration. You need turn-taking logic. You need interruption handling. You need prompt contextualization or rewriting, probably both. You also need some async process to handle any callouts to tools or function calls you need to actually make the agent do anything real, right? These are just the basics to create an actual really fluid real-time experience. So without these table stakes, you're really just going to end up with a very robotic, clunky experience that's slow and probably something that you're all used to when you call into your phone provider or your ISP, right? So Deepgram offers a full, complete offering around voice, everything from speech to text and text to speech, all of our custom and natural sounding voices, but we also wrap all of those up into a nice, easy to use voice agent API. So while you can use all of these little Lego blocks individually to build your own solution, you can also use our voice agent API to bypass all the complexity you're probably already dealing with. So our voice agent API was really designed around all of the use cases you're probably already considering. The voice agent can seamlessly listen, think, and speak. So the process here is to start streaming your audio in. So you get the audio in from the user, and the Deepgram voice agent API will leverage our Deepgram speech to text and listen. That turns it into text that you then feed as an output as an input into your LLM of choice, your large language model of choice. And then that produces some sort of thoughtful response. Hopefully, you've engineered the prompt, it's not hallucinating, et cetera, right? But then once you get the output, then you need to feed it back into possibly Deepgram's text-to-speech to produce a customized, natural sounding voice, right? And depending on your use case, you then need to tie all of your business logic, any integrations you need in order to affect any sort of actions or changes, all need to be incorporated, integrated to make sure it can affect other systems. So all of this stuff that I just described is what's happening under the hood. And this is very typical in terms of a standard kind of voice agent use case. But this complexity is completely abstracted away with our voice agent API, right? So you get a single API that does full voice agent orchestration as well as any behavior that you need to affect. So rather than stringing those listen, think, and speak functions together, you can build your voice agent automatically and take care of the complexity just using our single unified voice agent API. This creates a really true speech-to-speech experience. So next, I want to talk about Flux. So Flux we just launched last week, or the week before. And Flux is a world's first conversational speech recognition model, the first of its kind. This was designed from the ground up for building future gen voice agent products. It's a fused model which has integrated turn detection that provides a much more natural flow to the conversation. Not only do you get the fused and controllable turn detection, but you get sub 300 milliseconds, usually about 250 quarter second turn detection with full confidence thresholds. So not only while the conversation is happening, you're getting a live transcript, but you're also getting the confidence intervals and values as the conversation is happening, so you can start affect actions or changes while the person is still speaking. And then these live transcripts let you start prepping agent replies, maybe start invoking some actions behind the scenes, and this will help you create totally new experiences that aren't even possible today. Not only that, but it comes with the best-in-class accuracy of Nova 3's transcription model built by Deepgram. So let me just show you what I'm talking about here. This is a plot showing F1, which is a combination of precision and recall. On the y-axis, we have accuracy. On the x-axis, we have latency. And what you're seeing here is pretty clear why Flux is so much better and so much different in conversations today. It dominates the top the top right quadrant in F1, whereas some of the competing approaches end up scattering across this accuracy and speed trade-off curve. So then your choice becomes, do you interrupt the user all the time, or do you have these long, robotic pauses that are frustrating as a human, right? Flux eliminates this false choice altogether, right? It consistently delivers both rapid response and high accuracy, and I'm going to show you that in a few minutes. But before I get there, I want to talk about how we actually measure these things and what that actually means. So voice needs to be evaluated differently. It's not text, right? And voice agents themselves also need to be evaluated differently. So we've introduced this concept called VAQI, V-A-Q-I, which is the Voice Agent Quality Index. And this measures three things that are really important in terms of evaluating how your voice agent is actually functioning for your customers. So this includes interruption rate, latency, as well as response coverage. And so this actually helps you benchmark the agent where it actually matters, not bringing along some archaic metric that you think might help or think might give you the visibility. You actually need to measure where the rubber hits the road. And then finally, before I get to the demo, deployments are hard, right? I think everyone understands, especially working in the gov space, federal space, enterprises need voice infrastructure to run where they are. So we offer self-hosted deploys that meet strict privacy requirements for our household name healthcare and financial services customers. We support both public, private clouds, on-prem, dedicated deployments, as well as air-gapped deployments for the most sensitive customers. And we support that across the globe from North America, EU, as well as Asia Pacific. So let's start with our demo. So let's talk about Flux. So this is I'm gonna show you Flux live. What this is doing, it'll be transcribing on the right with Nova. It wouldn't be fair to put OpenAI up here. But what I'll do is I'll show you on the left. And as I go, I will start talking. And as I start talking, maybe my mic's not working. Sorry. Hello, hello. Okay, I don't know what's going on with my mic. I think it hijacked my mic. I apologize, guys. You can check this out at flux.deepgram.com. So I'll have to show you this to you live, but there's something going on with the IT situation, and it's not taking my microphone. So anyway, let me just get going here, and I'll move on. So, all right, so lastly, before I close, I want to talk about what's coming next. So we're making huge strides towards the next generation speech-to-speech architecture, actual speech-to-speech architecture, not what a lot of people are saying is speech-to-speech. So today, the current approach is based on sequential processing, what we call a cascade, right? So you primarily involve text conversion. So you start with speech, you get your speech to text, then you have your LLM, and then you have your text to speech out, right? This cascade also applies to multimodal models, whether you're applying images, audio, video, et cetera. But you have this text as an intermediate format, right? Now, this approach works today in today's use cases, but it permits the loss of a lot of emotional and contextual nuance that happens when you do this translation to text. So on the top, right, we have 15,000 instances of the word hello being uttered, right? It all gets converted to 5 characters. It all gets normalized, and so you lose all of that important information. So you'll see at the bottom, we have 15,000 distinct utterances using Neuroplex, which is our latest speech-to-speech model. So this represents the full attributes of someone's voice. So we have this whole human-like representation of the voice, of the conversation, of the utterance, and this allows the whole system to pass through intonation, pacing, emotion, and context from the start of the conversation all the way to the end, not just in the last sentence that was uttered. And this is preserved all the way through. So what I mean by that is we've built observability directly into the stack. So this is not like really a new model itself, but it's a purpose-built stack where each major stage in the voice pipeline has adapters between the components, whether it's automated speech recognition, synthetic speech generation, or the LLM. Each of these components and each adapter exposes hidden intermediate states that lets you inspect and debug the code and outputs at any stage. We can trace, measure, and improve not just the final result, but what happens at every step of the way. In real time, Neuroplex tracks how long each stage takes down to the millisecond and surfaces issues such as latency spikes, barge-ins, or missed turns. This level of observability is essential, right? If you're building a real-time voice-first system, you can't afford a black box that you can't debug from some vendor. You need to know what's happening, when it happens, and why. And this is Neuroplex. So, in closing, I want to give you 5 kind of takeaways in terms of how to build these agents, right? So the first, voice isn't text, right? It's real-time, it's noisy, it's frequently multilingual, and the assumptions you made about chat-based agents don't hold up at all, right? We're talking about human nature. You can't change human nature. The second is orchestration is essential. Getting to sub 800 milliseconds, sub 500 milliseconds, end-to-end is absolutely essential in order to have a real fluid experience, right? It's not just about the model speed. It really depends on how tightly coupled your speech and reasoning layers are together and integrated and coordinated throughout the experience. The third is accuracy is not sufficient, right? You could have the best transcription engine in the world, but if your agent cuts people off, interrupts, or can't recover from the interruption, your experience falls apart really, really fast. Number 4 is you need new metrics, right? Word error rate is fine for simple transcription use cases, but for agents, you need to track real-world behavior that represent how the customer is experiencing the product, right? You need to look at latency, you need to look at response coverage, and you need to look at interruption rate. And lastly, deployment flexibility is a must, right? Enterprise voice agents need to run both public, private cloud, on-prem, air-gapped with private data. All these need to be included and considered, and these affect both the compliance and the user experience itself, right? So these are the principles we've seen across the various industries we serve, from healthcare, call centers, again, Krispy Kreme. This is what they care about, and this is our playbook. Thanks so much for listening. If you want to take a look, and you can actually play with Flux today in our playground, here's the QR code. Please take a look. I'll be answering questions here in a little bit. Thank you so much.